Next, please find out the number of hyperconjugation structures of these molecules. Fifth one. First to just sixth one. First to just seventh one. Eighth one. Please find out the number of hyperconjugation structures of these compounds. First of all, we have to take this one. This is having carbocation. This adjacent carbon is called alpha carbon. How many hydrogens are there? 1, 2, 3 carbons is there. Remain only one hydrogen is there. What is the hybridization of this carbon? sp3. Our condition is alpha carbon sp3 hybridized. Alpha carbon must have alpha hydrogen, at least one. This is the condition to show the hyperconjugation. First condition is satisfied. Second is having one alpha. That's why one hyperconjugation structure exists in this molecule. If you take this carbon adjacent carbon is this one having 2 hydrogens. This is having 3 alpha hydrogens. 3 carbons are shown the sp3 hybridized. 1, 2, 3, 4, 5, 6, 7. 7 alpha hydrogens are there. That's why it will show the 7 hyperconjugation structures. If you take this one, this carbon is the alpha carbon. This carbon is also alpha carbon. Both are having sp3 hybridization. 1, 2, 3. 3 alpha hydrogens are there. That's why 3 hyperconjugation structures will form. If you take this carbon, this is having 2 hydrogens. This is also having 2 alpha hydrogens. sp3 hybridization condition is satisfied. That's why this show the 4 hyperconjugation structures. If you take this molecule, this is having alpha carbon for this carbocation. 3 alpha hydrogens are there. This is also having 3 alpha hydrogen. This is having 1 hydrogen. All are sp3 hybridized. Total 3, 3 plus 6, 7. 7 hyperconjugation structures are exist in this molecule. If you consider this one, this carbon is alpha carbon for this carbocation. This carbon also alpha carbon. For this also, this is having also alpha carbon. Total how many sp3 hybridization is satisfied? Total how many alpha hydrogens are there? 1, 2, 3, 4, 5. That's why this shows the 5 hyperconjugation structures. If you take this one, in this having 3 alpha hydrogens, this is also having 3 alpha hydrogens. This will show the 2 alpha hydrogen. Total, this is also alpha carbon. This is 3 alpha carbons are there. How many alpha hydrogens are existed? Total 1, 2, 3, 4, 5, 6, 7, 8. 8 alpha hydrogens are existed. That's why it shows the hyperconjugation structures. If you take this carbocation, this will shows the 3 alpha hydrogens. This is 2 alpha hydrogens. These 2 are adjacent carbon to this carbocation. It having total 3 plus 2, 5 hyperconjugation structures are exist. This is the to calculate the hyperconjugation structures of the molecule in case of carbocation. You can drop this one. In case of alkene, for example, if you take this is alkene, this carbon is called alpha carbon. In case of alkene, in which compounds are shown the hyperconjugation? 3. Can discuss carbocation, carbon radical, and alkene. This will show the hyperconjugation. Next we will discuss. In case of this total functional group is considered as alkene. This alkene adjacent carbon is called as alpha carbon. This alpha carbon having sp3 hybridized and alpha carbon at least one alpha carbon hydrogen is must be present, then only it will show the hyperconjugation. This is very important. How the structures are formed? If in case this, take this one, how the mechanism will, if you break this one, what will form? If you break this one, H2 double bond H2. If you break this one, it will form H plus, this bond shifted to this one, this bond shifted to this one, double bond C, CH2 minus. If in case of break this one, it will form, this is hydrogen, double bond CH2, CH2 minus. If you break this one, this is the mechanism, CH2 minus. These three are the, this is the mechanism of the, in case of alkene. If you take in case of free radical, how it will show? In this also, you can write. If you take this free radical, how it will form? This will form, this is break two radicals, then it will form this radical shift to this one, this radical is shift to this one, then it will form the, this one, this is the radical, this radical, this will form double bond, it will form the CH2. If you break this one, what will form? This is the radical, this will form the double bond, then it will form CH2. If you break this one, same like this structures is existed. In this is also same. Condition is must be in all three cases it will same. To take in case of free radical, how can I identify? To take examples. To take for example, in case of alkenes, we have to find first of all in case of alkene, later we in case of free radical examples. If you take this one, if you take this one, if you take this one, for example, if you take this one, take this one, please find out the hyperconjugation structures of these molecules. How to calculate this hyperconjugation? First of all, this group is considered as a main group function group. Then later this carbon is called as a alpha carbon. Alpha carbon must be show the sp3 hybridized is having alpha hydrogens. This is having 3 alpha hydrogens. That's why this is shows the 3 alpha hyperconjugation structures will exist. This is the main functional group alkene. This adjacent carbon is called alpha carbon. This adjacent carbon is also called alpha carbon. Alpha carbon must be sp3 hybridized. This is also sp3 hybridized. It will shows the 3 plus 6 hyperconjugation structures will exist in this molecule. If you take, this is the main functional group, this is one of the alpha hydrogen, this is also one of the alpha hydrogen, total 6. This is also shows the 6 hyperconjugation structures. In case of this one, this is all considered as a alkyl group. This is having adjacent carbon, this is having 3 this is also having adjacent alpha carbon, sp3 hybridized, total 5 hyperconjugation structures will exist in this molecule. If you take this one, this is alpha carbon, in this case this is the alpha carbon, this is having 1 hydrogen, this is having 2 hydrogen, total 3 hydrogens are there. That's why 3 hyperconjugation structures will exist in this molecule. If you take, this is the functional group, main alkene group, this adjacent carbon is called alpha carbon, this is adjacent carbon is called alpha carbon, total 4 alpha hydrogens are existed. That's why it shows the 4 hyperconjugation structures. This is the how to find out the in case hyperconjugation structures in case of alkene. Next we discuss about the in case of free radical. Free radical is same like that in carbocation. Take this one, same. Take one of the radical here, 3. If you take for example radical here, next radical here, next here, then we can find out the, I will give the example. We did the homework in the to calculate the hyperconjugation structures of this carbon is adjacent carbon is called alpha carbon. Alpha carbon shows how many having alpha hydrogens, then it will can identify easily the hyperconjugation structures of this molecule. Next we discuss about the overlapping approach. How the overlapping will approach. This is very important in case of overlapping approach. How we can calculate the overlapping approach. In case of carbocation, this is the hydrogen, this is the carbocation. You take this one hydrogen, this is hydrogen. Take overlapping approach. How will bond formed? Take overlapping approach. This is the carbon having 1, 2, 3, 4. It will having 4 sigma bond with the hydrogen. It will form 4 sp3 hybridized carbon. 1 p orbital, 3 p orbital carbon having. This is the 4 sp3 hybridized orbital. This is in 1s orbital hydrogen. This carbon form 4 sp3 hybridized with form a sigma bond. This hydrogen will form a sigma bond with this one. This is called as a sigma bond. Same this hydrogen with another sp3 hybridized will form the another sigma bond. This hydrogen also same with the sigma bond. This is sp3 high plus 1s sigma bond. 1 sp3 carbon plus this 1s hydrogen sigma bond. 1 carbon 3 carb plus with 4 hydrogens will form the sp3s sigma bond. In case of carbocation, this is the vacant p orbital, positive charge. This sp3s sigma bond will form the bonding with this vacant p orbital. What is the overlapping? Sigma bond will form the vacant p orbital. Overlapping will happen in this case alpha carbon. Next, in case of hybridization, in case of molecular orbital theory, we can discuss more. This carbon having sp3 hybridized. How many sp3 hybridized are? 4 sp3 hybridized orbitals. This is the sp3 hybridized orbital. Next, this is the hydrogen. Hydrogen form bond with the carbon through sigma bond. How will sigma bond form? One of the sp3 hybridized carbon orbital plus 1 s orbital of the hydrogen will form the sigma bond. That is the sigma bond of this one. In case of this is the carbon having a positive charge. That's why it is a vacant p orbital. Carbon having the p orbital. Remove the electron from the p orbital, then it will form the carbocation. That is the vacant orbital. This is the carbon hydrogen sigma bond. This will break, will form the, this is these 2 electrons donate to this vacant orbital, it will form the bond carbon. That's why this is called as a sigma p. P vacant orbital. Vacant orbital, it will donate the sigma electrons towards the vacant p orbital. That's why this is called as a sigma vacant p orbital overlapping. In case of carbocation. If you take in case of free radical, this is same. What will happen? In case of free radical, how it will happen? Same. This is the 1s orbital, sp3 hybridized. This is 1s orbital. This is sigma 1. This is donated the electron towards the. This is off field. One of the electron is less off field p orbital. This is carbon. The sigma bond donated to the off field p bonding. That's why this is called as a sigma off field p orbital overlapping. This is in case of free radical. This is in case of carbocation. In case of, if you take in case of alkene, how it will happen? This. This is in case of alkene. This is this is sp3 hybridized. This is s orbital. It will form the sigma 1. This is the sigma 1. It will donate the electrons towards the. In case of alkene, in which case it will vacant orbital is there, p orbital. In pi star anti-bonding, only vacant orbital, remaining are filled. That's why it's donate sigma electrons towards the vacant pi star orbital. Pi star, vacant pi star orbital. Can more discuss in chemical bonding, vacant pi star. That's why this is called sigma vacant pi star orbital overlapping. In this case, sigma electrons donate towards the vacant pi star orbital. Pi star only vacant, remaining all are filled. That's why this is sigma vacant pi star overlapping will be present in this case. Bonding, chemical bonding off field. This is the sigma pi star, vacant anti-bonding. This is anti-bonding pi star. Anti-bonding pi star. This is the overlapping of the electrons. This is the so far discussed. Next, this effect is called also called as this effect is called Becker-Nanton effect, no bond resonance, and also call it as a Becker-Nanton effect, no bond resonance, and chimeric effect. These are the this is the hyperconjugation effect. Next, so far what we have discussed, we have summarized. First of all, we have what is not required definition. Hyperconjugation. Hyperconjugation, one of the, after discussion of the inductive effect, we have discussed the hyperconjugation, and hyperconjugation we have in which molecule it is show the hyperconjugation. In carbocation, free radical and alkene only will show the hyperconjugation. What is the condition for hyperconjugation? In these three above molecule, the alpha carbon must be having sp3 hybridization. Alpha carbon must have at least one alpha hydrogen, then only will show the hyperconjugation. In hyperconjugation, in carbocation, how will it affect in free radical? Examples, number of hyperconjugate structures in case of alkene. After that, overlapping of these orbitals, how it is overlapping approach will there in the molecule. Then that is also we have to discuss. Next, this is the this is about the hyperconjugation. Next we have to discuss next class isomeric effect resonance. Thank you.